Hello everyone. Welcome to the Listen and Sleep channel. The channel shares good, meaningful books that you should listen to before falling asleep. In today's video, we start with Chapter 1 of the Deep Work book. Chapter 1. Deep Work is Worthy. When Election Day cast a shadow over the entire United States in 2012, traffic to the New York Times website suddenly spiked, a common occurrence during critical national moments. But this time, something was different. According to some reports, over 70%, an extremely disproportionate percentage, of the website's visits were directed to a single page. It wasn't a headline-grabbing news story, nor was it a column by one of the Pulitzer Prize-winning editors. It was a blog post predicting the election results, created by a baseball statistics-obsessed data geek named Nate Silver. In less than a year, both ESPN and ABC News tried to lure Silver away from the Times. The latter even offered him a deal that included a promise to recruit a team of writers in an important negotiation, which would allow him to work across various fields, from sports, weather, and online news sections to the Academy Award-winning television shows. While debates raged about the rigor of Silver's manual adjustment models, few could deny that, in 2012, this 35-year-old data wizard was the real winner in our economy. Another example is David Heinemeier Hansson, the computer programming star and author of the Ruby on Rails web development framework, which powers some of the most popular social media platforms, including Twitter and Hulu. Hansson is a partner at Basecamp, a highly influential software development company. While he doesn't publicly disclose how much he earns from Basecamp's profit sharing or other revenue sources, it's safe to assume that his income is substantial, given that Hansson splits his time between Chicago, Malibu, and Marbella, Spain, where he often immerses himself in Formula One races. The third and final example is John Doerr, a partner at the prestigious venture capital firm Kleiner Perkins Canfield and Byers in Silicon Valley. Doerr has helped this investment firm and many tech giants spark the current revolution, including Twitter, Google, Amazon, Netscape, and Sun Microsystems. The profits from these investments have been enormous. Doerr's net worth at the time of writing this book is over $3 billion. Why have Silver, Hansson, and Doerr been so successful? There are two types of answers to this question. The first is micro in nature, focusing on personality traits and strategies that have driven the rise of these three individuals. The second answer is more macro, shifting the focus away from the individuals themselves and turning attention to the type of work they represent. While both approaches are important, the macro answer is more relevant to the topic we are discussing, as it sheds light on what today's economy has to offer us. To explore the macro perspective, we turn to two MIT economists, Eric Brynjolfsson and Andrew McAfee, authors of the influential 2011 book Race Against the Machine. The book makes a compelling case. The rise of digital technology has dramatically transformed the labor market in unexpected ways. Brynjolfsson and McAfee explain in their book, "We are living in the midst of the great restructuring. Technology is racing ahead, while skills and organizations lag behind. For many workers, this lag holds bad news. As smart machines improve, the gap between machines and human abilities narrows, and employers are increasingly likely to hire new machines rather than new people. At that point, advances in communication and coordination technologies will make online work easier than ever, incentivizing companies to outsource key roles to stars while leaving behind a large pool of talented workers doing underwhelming jobs within organizations. However, the reality is not so harsh. As Brynjolfsson and McAfee analyze, the Great Restructuring does not reduce jobs. Rather, it divides them. While the number of people failing in the new economy is increasing, as their skills have been automated or easily outsourced, there are others who not only survive but thrive, becoming more valuable and thus more rewarded than before. Brynjolfsson and McAfee are not the only ones to offer this bipolar trajectory for the economy. For example, in 2013, George Mason economist Tyler Cowen published the book Average is Over to present a similar argument about the widening digital divide. But what makes Brynjolfsson and McAfee's analysis particularly useful is that they identify three specific groups that are benefiting from this divide and gaining asymmetric advantages in the age of smart machines. Unsurprisingly, Silver, Hansen, and Dorr all belong to these three groups. Let's address each of these groups in turn to better understand why they have suddenly become so valuable. The digital divide, or the digital gap, refers to the economic and social inequality in access to and use of information and communication technologies. GPA, grade point average, a system used in the United States to measure a student's academic performance. The example of Adam Grant shows that this intensity formula also applies to GPA and other tasks that require cognitive effort. But why is that? Sophie Leroy, a professor of business at the University of Minnesota, provided an interesting explanation. In a 2009 study titled provocatively, "Why is it so hard to do my work?" Leroy introduced a concept she calls attention residue. In the introduction to her study, she pointed out that other researchers have studied the effects of multitasking, the effort to complete multiple tasks at once, on performance. However, she argued that in modern intellectual environments, once you reach a certain level of proficiency, it becomes more common to work on multiple projects consecutively. Moving from one meeting to another, starting one project, and quickly switching to another is part of life in organizations, Leroy explains. The problem with this multitasking strategy is that when you switch from task A to task B, you don't immediately focus on the new task. The residual attention from the previous task lingers in your mind. This residue is particularly heightened if your work on task A was left incomplete or low in intensity before you switched. But even if you finish task A before moving on, your attention will still be fragmented for a period of time. Leroy studied the impact of this attention residue on performance by forcing participants to switch tasks in a laboratory setting. For example, in one experiment, she had participants work on a set of crossword puzzles. In some trials, she interrupted them and told them they needed to start a new task, a challenging one, such as reading resumes and making mock hiring decisions. In other trials, she allowed them to finish the puzzles before assigning the new task. Between the crossword puzzle and the hiring task, she had them play a quick vocabulary game to measure the attention residue left from the first task. The results of this experiment and similar studies showed clearly, people who experience attention residue after switching tasks perform worse on the next task, and the more residue there is, the lower the performance. The vocabulary game displayed brief strings of letters on the screen. Some formed real words, while others did not. Participants had to decide as quickly as possible whether the string formed a real word, and then press one button for real and another for not real. These tests allowed Leroy to quantify which keywords were activated in the participants' minds, as the activation would cause them to press the real button more quickly when they saw the word appear on the screen. The concept of attention residue helps explain why the intensity formula works, and also explains Grant's performance. By performing a challenging task for an extended period without switching, Grant minimizes the negative effects of attention residue, allowing him to maximize his performance on that single task. In other words, when Grant isolates himself for several days to focus on a paper, his work efficiency is much higher than that of a typical professor who follows a more distractible strategy, with their work constantly interrupted by a stream of attention residue. Even if you can't fully replicate Grant's extreme isolation process, we'll delve into different strategies for deep work planning in Part 2. The concept of attention residue still demonstrates the effectiveness of deep work because it shows that common work habits in a state of partial distraction can actually sabotage your performance. Checking your inbox every 10 minutes might seem harmless. In fact, many people argue that this behavior is much better than the outdated habit of leaving the inbox open on your screen, a silly habit that few people still practice. But Leroy has shown us that, in reality, this is no improvement. The act of checking pulls your attention toward new goals. Worse, seeing messages you can't address at the moment, which is quite common, forces you to return to the original task while the second task remains unfinished. The attention residue left by this half-hearted switching lowers your performance. Taking a step back to assess this from a personal perspective, it becomes clear. To produce work at an excellent level, you need to dedicate your full attention to one task and not be distracted for an extended period. In other words, The form of work that optimizes your performance is deep work. If you're not comfortable immersing yourself in work for long periods, it will be difficult to achieve peak performance and enhance your expertise. If your talent and skills don't give you a clear edge over your competitors, those who practice deep work will surpass you. SQL is a popular programming language used to create, modify, and retrieve data from relational database management systems. Now, back to Nate Silver. Let's consider the other technology he relies on, Stata. This is a powerful tool and certainly not something you can learn by just doing a cursory glance. For example, here's a description of the additional features in the latest version of the software. Stata 13 adds many new features such as treatment effects, multi-level GLM, power and sample size, generalized SEM, forecasting, effect size, project management, long strings, and blobs. Silver uses this complex software, along with generalized SEM and blobs, to build complex models with nested components, multiple regressions, performed on custom parameters, and then referenced as custom weights used in probability expressions and so on. We provide these details to emphasize that smart machines are complex and difficult to master. Therefore, to join the group of people who can work well with these machines, you must hone the ability to tackle tough problems. Furthermore, because these technologies are constantly evolving, this process of mastery will never end. You need to be able to learn quickly and repeatedly. This type of database is queried using SQL. You send commands like the ones above to interact with the stored information. Understanding how to use these databases is extremely challenging. For example, the command in the previous example creates a view, a simulated database table that consolidates data from multiple existing tables into one place, and then the table can be processed with SQL commands just like a standard table. When and how to create views is not a simple question, and one of the answers is that you need to understand and master how to generate meaningful results from real-world databases. SQL, Structured Query Language, is a common computer language used to create, modify, and retrieve data from a relational database management system. Now, let's return to our example of Nate Silver and the technology he relies on, Stata. This is a powerful tool, and certainly not something you can learn just by skimming the surface. For example, here's a description of new features in the latest version of the software. Stata 13 adds many new features like treatment effects, multi-level GLM, power and sample size, generalized SEM, forecasting, effect sizes, project management, time series, and blobs. Silver uses this complex software, along with generalized SEM and blobs, to build sophisticated models with interwoven components, multiple regression runs conducted on custom parameters, which are then referenced as custom weights used in probability expressions, etc. We provide these details to emphasize that smart machines are very complex and hard to master. Therefore, to join the group that can work effectively with these machines, you must develop the ability to grasp difficult concepts. Furthermore, because these technologies evolve rapidly, this learning process will never end. You need to be able to learn quickly and repeatedly. The reality of the complex technology that companies use to succeed highlights the absurdity of the current widespread belief that we should aim for simple, user-focused products, especially in schools, by equipping students with tools to succeed in the high-tech economy. Allowing them to use iPads or record their homework and post it on YouTube will prepare them for the new economy, like playing Hot Wheels, a racing game with obstacles, ed. Will prepare them for success in the field of mechanical engineering, ed. Of course, this ability to learn quickly is not only necessary when working with smart machines. It is also crucial in your efforts to become a superstar in any field, even if your expertise has little to do with technology. For example, becoming a world-class yoga instructor requires mastering increasingly complex physical skills. Another example, if you want to excel in a particular medical field, you must quickly learn the latest research on related procedures. In short, if you can't learn, you won't grow. Now let's consider the second core ability in the list above, producing high-quality results. If you want to become a superstar, mastering the relevant skills is necessary, but not enough. You also need to be able to turn potential into tangible outcomes that others can value. For example, many developers can program computers very well, but David Hansen, a superstar in the example we mentioned, leveraged his abilities to create Ruby on Rails, the project that made him famous. Ruby on Rails required Hansen to push his current skills to their limits, producing results that were both valuable and meaningful. Skilled workers Brynjolfsson and McAfee refer to the group represented by Nate Silver as skilled workers. Advances such as robotics and voice recognition are automating many low-skill jobs, but as these economists emphasize, other technologies like data visualization, analytics, high-speed communication, and rapid prototyping have contributed significantly to more abstract, data-driven reasoning, which increases the value of these jobs. In other words, those who can work with technology and produce valuable results from increasingly complex machines will have the opportunity to grow. Tyler Cowen summed up this reality bluntly. The key question will be, are you good at working with smart machines? Of course, Nate Silver is the quintessential example of a skilled worker. Smart machines are not an obstacle to his success. On the contrary, they are a critical component that enhances that success. Superstars programmer David Heinemeier Hansen is an example of the second group Brynjolfsson and McAfee predicted would rise strongly in the new economy, the superstars. High-speed data networks and collaboration tools like email and virtual meeting software have destroyed localism in many knowledge-based fields. For example, instead of hiring a full-time programmer and dealing with office space issues and employee benefits, you can hire one of the best programmers in the world, like Hansen, for just the amount of time needed to complete a project. In this scenario, you get a better result for less cost, while Hansen serves more clients per year, making it a win-win for everyone. Hansen's ability to work remotely from Marbella, Spain, while your office is in Des Moines, Iowa, is no problem for your company thanks to advances in communication and coordination technologies that have made remote work almost flawless. However, this reality presents a problem for lower-skilled local programmers living in Des Moines who rely on a steady income. A similar trend is happening across many fields where technology has made remote work more efficient and productive, such as consulting, marketing, writing, and design. As the talent market becomes more accessible, those at the top of the market will thrive, while the rest are left behind. In a seminal study for a 1981 conference, economist Sherwin Rosen uncovered the formula behind winner-takes-all markets. One of the key components that make up his model of talent, randomly assigned to the variable Q in the equation, is a factor with imperfect substitutability, which Rosen explains as, hearing a bunch of mediocre singers is not the same as hearing one outstanding performer. In other words, talent is not a commodity you can purchase in bulk and combine to reach the necessary levels. Rewards are reserved for the very best. Therefore, if you are in the marketplace, where buyers have access to all the sellers and the value queue of each is clear, buyers will choose the best. Even if the talent advantage of the best is only slightly higher, the superstars will still capture a disproportionate advantage in the market. In the 1980s, when Rosen conducted his research into this effect, he primarily focused on movie stars and musicians, where clear markets already existed, such as music stores and movie theaters, where audiences could access various performers and accurately estimate their talent before making a purchasing decision. The rapid development of communication and coordination technologies has transformed many local markets into a global marketplace. A small company looking for a computer programmer or a public relations consultant can now access a global talent pool in much the same way that music fans in small towns bypassed local musicians to buy albums from the top bands in the world. In other words, the superstar effect today has a far wider reach than Rosen predicted 30 years ago. Owners, the final group, which has also thrived in our new economy, represented by John Doerr, consists of those who have invested capital in new technologies that are driving the Great Restructuring. As we've known since Marx, access to capital has provided huge advantages. However, some periods give you more advantages than others. As Brynjolfsson and McAfee pointed out, post-war Europe is a perfect example of a bad time to sit on a pile of money, as the combination of rapid inflation and heavy taxation wiped out old fortunes at an astonishing speed, what we might call the Downton Abbey effect. The Great Restructuring, unlike the post-war period, is a golden time to access capital. To understand why, let's first review bargaining theory, a key element of standard economic thought. This theory argues that when people can make money through a combination of capital investment and labor, they will earn a return roughly proportional to their inputs. Since digital technology has reduced the need for labor in many industries, the returns for those who own smart machines are increasing. A venture capitalist in today's economy might invest in Instagram, a company that was sold for $1 billion while employing only 13 people. Is there any period in history when such a small number of workers created such immense value? With such a minimal labor input, the returns on investment for the owners of the machines, in this case, the venture capitalists, are unprecedented. No wonder a venture capitalist I interviewed for my latest book admitted with some concern, "Everyone wants my job." Let's summarize the topics we've discussed so far. As I've explored, modern economic thinking argues that unprecedented developments and the impact of technology are causing a massive restructuring of the economy. In this new economy, the following three groups will have distinct advantages. Those who can work well and creatively with smart machines, those who are the best in their field, and those who can access capital. Clearly, the Great Restructuring, as economists like Brynjolfsson, McAfee, and Cowan have noted, is not the only important economic trend right now, and the three groups mentioned above are not the only ones that will succeed. But what's crucial is that while these trends are not the only ones, they are very important, and these groups will continue to exist and thrive. So, if you can join any one of these groups, you'll do well. If not, you may still do well, but your position will be more precarious. The question we now face is clear. How can we join the ranks of the winners? While this may dampen some of the enthusiasm in you, I must confess that there is no secret to quickly accumulating capital and becoming the next John Doerr. If there were, I wouldn't be sharing it in a book. However, you can still join the other two winning groups. Our next goal is to figure out how to get into them. How to become a winner in the new economy. I have identified two groups with the potential for significant growth. Those who can work creatively with smart machines, and those who are stars in their respective fields. What is the secret to creating profitable fields with an ever-widening digital divide? I believe it comes down to two core abilities. Two core abilities for thriving in the new economy. 1. The ability to quickly grasp difficult problems. 2. The ability to produce high-quality products at high speed. Let's start with the first ability. It's important to remember that we are often drawn to the intuitive and user-friendly experiences of consumer-facing technologies like Twitter and the iPhone. However, these examples are just products for consumers, not serious tools. Most of the smart machines driving the Great Restructuring are much more complex, harder to understand, and harder to master. Take the case of Nate Silver, a clear example of someone who has thrived by effectively working with complex technology. A closer look at his methodology reveals that making election predictions based on data is not as simple as typing who will get the most votes into a search box. Instead, he maintains a large database of polling results, thousands of polls from more than 250 polling organizations, to input into Stata, a popular statistical analysis system produced by Stata Corp. These are not easy tools to master. For example, here's a command you need to understand to work with a modern database like the one Silver uses. Create View Cities AS select name, population, altitude. From capitals Union select name, population, altitude. From non-under capitals. This kind of database is queried using SQL, structured query language. You send commands like the one above to interact with the data stored. Understanding how to work with these databases is incredibly difficult. For instance, the command above creates a view, a simulated database table that combines data from multiple tables into one place. The table can then be processed using SQL commands, just like a standard table. When to create views and how to do it is no simple question. One answer is that you need to understand and master how to derive meaningful results from real-world databases. In a paper titled Why Expert Performance is Special and Cannot be Extrapolated from Studies of Normal Performance, a response to critics, published in Intelligence 45, 2014 81 to 103, Erickson refuted many of these studies. Among his arguments, he stated that the experimental frameworks of these critiques were often incomplete, as they assumed that the differences between normal and above-normal individuals in a given field could be extrapolated to the differences between experts and non-experts. This brings us to the question: what exactly does deliberate practice require? The core elements are typically understood as follows: putting your full focus into a specific skill you are trying to improve or an idea you are trying to grasp, receiving feedback to adjust your methods to maintain attention and precision on the most productive areas. The first element is especially important for our discussion, as it highlights that deliberate practice cannot coexist with distraction. It demands uninterrupted focus. As Erickson emphasizes, distractions are nearly the opposite of the focused attention that deliberate practice requires. Psychologists like Erickson and other researchers in this field are not interested in answering why deliberate practice works. They just consider it an effective behavior. However, after Erickson's important early research on this topic, neuroscientists have discovered the physical mechanisms that govern human progress in difficult tasks. According to journalist Daniel Coyle's The Talent Code, 2009, scientists are increasingly convinced that the answer lies in myelin, a fatty tissue that wraps around neurons, acting as insulation and allowing the cells to fire faster and more efficiently. To understand the role of myelin in progress, remember that skills, whether intellectual or physical, ultimately relate to brain circuits. This emerging science of performance argues that when you hone a skill, you also create more myelin around the related neurons, making the corresponding circuit fire more easily and effectively. This understanding is crucial because it provides a neurological basis for why deliberate practice works. By intensely focusing on a specific skill, you promote the firing process of the related brain circuit, and this process is repeated multiple times within the myelin sheath. The continuous use of these activating cells forms oligodendrocytes, a type of glial cell, which start wrapping myelin layers around the neurons in that circuit, strengthening the skill. Therefore, the importance of high-level focus and avoiding distraction lies in the fact that this is the only way to isolate the relevant neural circuit enough to trigger the myelin-producing process. Conversely, if you try to learn a complex new skill, such as SQL database management, while distracted, perhaps by Facebook's news feed, you will overfire too many circuits at once and haphazardly, preventing you from isolating the specific neurons you want to strengthen. In the century since Antonin Dalmas-Sertalanges first wrote about using the mind as a lens for converging rays of attention, we've moved from this elevated metaphor to a clearer, though less poetic, explanation involving oligodendrocytes. At the same time, this leads to an inevitable conclusion. To quickly learn difficult problems, you must focus intensely and avoid distractions. In other words, learning is an act of deep work. If you're comfortable concentrating, you'll also be comfortable mastering increasingly complex and essential systems and skills needed to thrive in the economy. On the other hand, if you always feel restless and distracted, don't expect these systems and skills to come easily. Deep work helps you create excellent products. Adam Grant has worked at an exceptional level. When I met Grant in 2013, he was the youngest professor ever appointed to the Wharton School of Business at the University of Pennsylvania. A year later, when I started writing this chapter and was just beginning to think about my own appointment process, I heard the news. Now Grant was the youngest professor at Wharton. In the United States, there are 3 ranks for professors: assistant professor, associate professor, and full professor. According to the process, you are hired as an assistant professor and promoted to associate professor after being tenured. Full professor is a title that usually requires many years of achievements and significant contributions to a field. The ability to produce results also applies to those who want to understand smart machines. For Nate Silver, it wouldn't have been enough to simply learn how to use big data sets and run statistical analyses. He needed to prove that he could use those skills to extract meaningful insights from machines that attracted widespread attention. Silver worked with many statisticians during his time at Baseball Prospectus, but only he made the effort to adapt these skills to the emerging and potentially profitable field of election prediction. This provides another perspective on joining the ranks of the winners in the economy. If you don't act, you won't grow, no matter how skilled or talented you are. Baseball Prospectus is a company that provides statistical data related to baseball. Ed. After establishing the 2 core abilities necessary for success in a technology-disrupted world, we now come to the next question. What should we do to hone these core abilities? This brings us to the main argument of this book. Both core abilities described depend on your ability to work deeply. If you haven't mastered this basic skill, you will struggle to learn difficult concepts or produce high-level results. This dependency is not immediately apparent. It requires a scientific approach to learning, focus, and productivity. The following chapters of the book will provide you with a clearer perspective. Deep work helps you quickly learn difficult things. Let your mind become a lens with the converging rays of attention. Let your soul be filled with enthusiasm for a central idea that occupies your entire mind. This advice comes from Antonin Dalmas Sertalanges, a Dominican monk and philosophy professor who wrote the influential book The Intellectual Life in the early 20th century. Sertalanges wrote the book as a manual addressing the development and deepening of the mind for those who live in the world of ideas. Through The Intellectual Life, Sertalanges recognized the need to master complex elements and helped readers prepare to face this challenge. His book has proven useful in helping people quickly grasp difficult, cognitive skills. To understand Sertalanges' advice, let's look at the quote above. This passage is presented in various forms in The Intellectual Life, where Sertalanges argues that to elevate your understanding in any field, you must systematically grasp related topics, allowing the converging rays of attention to uncover the truths hidden within each subject. In other words, he suggests that you must focus deeply when learning. This idea turned out to be ahead of its time. In the 1920s, while reflecting on the journey of the mind, Sertalanges discovered the truth about mastering cognitively demanding tasks, a process that academia wouldn't formalize until 7 more decades passed. The formalization of this idea began in the 1970s, when a branch of psychology, sometimes called performance psychology, began systematically exploring what distinguishes experts across many fields from others. In the early 1990s, Anders Ericsson, a professor at Florida State University, compiled clues to form a coherent answer to this growing body of research, giving it a convincing name: deliberate practice. Ericsson began his essay on this new topic with a bold statement. We disagree with the view that these differences between experts and novices are immutable. Instead, we conclude that the differences between experts and non-experts reflect a lifetime of deliberate effort to improve performance in a specific area. Particularly, American culture loves extraordinary stories. Do you know how easy this is? Matt Damon's character in Good Will Hunting humorously solves a complex math problem that had stumped some of the world's top mathematicians. Ericsson pioneered this area of research, which has since become widely accepted, ahead of predictions, making these fantastical stories less popular. To master a cognitively demanding task, you must engage in this specific form of practice, though there are some exceptions for innate geniuses. On this point, Sertalanges seemed ahead of his time when he argued in The Intellectual Life. Geniuses are outstanding because they dedicate all their capacities to what they decide to excel in. Ericsson couldn't have said it better. After Malcolm Gladwell popularized the idea of deliberate practice in his 2008 bestseller Outliers, The Story of Success, the concept became a trend in psychology, a field that is generally skeptical of most of Gladwell's ideas. Many have poked holes in the hypothesis of deliberate practice. However, most of these studies do not dismiss the necessity of deliberate practice. Instead, they attempt to show that other factors also contribute to expert performance. The reason Grant advanced so quickly in academia is quite simple. He worked hard. In 2012, Grant published 7 papers, all of which appeared in major journals. This is an absurdly high rate in his field. Professors tend to work either alone or in small collaborative groups, often without large teams of students or postdocs to assist with their research. In 2013, that number dropped to 5, which is still an absurdly high rate even though it did not meet his own standard. However, he could also point out that same year, he published a book titled Give and Take, which helped promote some of his research on business relationships. Calling the book a success doesn't quite do it justice. It was featured on the cover of New York Times Magazine and continued to be a widely popular bestseller. When Grant was awarded the title of full professor in 2014, in addition to the book, he had written over 60 peer-reviewed papers. Not long after meeting Grant, when I was still preoccupied with my own academic career, I couldn't help but ask him about his extraordinary work output. Fortunately for me, he was happy to share his thoughts on the subject. It turned out that Grant spent a lot of time thinking about how to produce work at an excellent level. For example, he sent me a set of PowerPoint slides from a seminar he had attended with other professors in the field. The event focused on data-driven observations about how to produce academic papers at an optimal level. The slides included pie charts detailing time allocation for each season, a flowchart tracking development in relationships with co-authors, and a reading list with over 20 suggested items. These business professors didn't live in the mold of academic work that's vague and detached from real-world application, occasionally stumbling upon a big idea. They treated performance as a scientific problem to be solved systematically, a goal that Adam Grant seems to have achieved. Although Grant's performance depends on many factors, one particular element seems to be at the core of his method: organizing difficult but important intellectual tasks into a long, uninterrupted sequence. Grant practices this kind of focus on multiple levels. During the year, he schedules his teaching work in the fall semester, during which he can focus entirely on teaching and always be available for his students. This method seems effective, as Grant is now the highest-rated teacher at Wharton and has won multiple awards for his teaching. By focusing his teaching efforts in the fall, Grant is then able to devote his full attention to research during the spring and summer with fewer distractions. Grant also focuses his attention within shorter time frames. During his research semesters, he breaks his work into phases, sometimes leaving his office door open to meet with students and colleagues, and at other times isolating himself to fully focus and avoid distractions while researching. Essentially, he breaks academic research into 3 separate tasks: data analysis, drafting full papers, and editing drafts into final works. During these phases, which can last up to 3 or 4 days, he often sets up an out-of-office email reply so that people don't expect a prompt response. He told me, "Sometimes that confuses my colleagues. They say, 'You're not going anywhere. I see you in the office.'" But for Grant, enforcing strict isolation until the task is finished is what's important. I suspect that Adam Grant doesn't actually work more hours than professors at top research institutes. Generally, this group tends to be workaholics, but he still manages to produce more than anyone else in his field. I believe the key to this paradox lies in his approach to organizing work. Specifically, by structuring his work into high-intensity, uninterrupted blocks, he takes advantage of the following performance principle: high-quality work output equals time invested times focus intensity. If you believe in this formula, it becomes clear why Grant's habits make so much sense. By maximizing his work intensity, he has been able to maximize his output per unit of time. This isn't the first time I've come across the concept of performance being expressed in this formulaic way. The first time was when I was researching my second book, How to Become a Straight-A Student, many years ago. During my research, I interviewed about 50 college students with excellent grades from one of the most competitive universities in the United States. What I discovered from these interviews was that the best students often studied less than those with lower GPAs. One explanation for this phenomenon turned out to be the formula above. The best students understand the role that focus intensity plays in performance, so they do whatever they can to maximize their focus, significantly reducing the time they need to prepare for tests or write research papers without sacrificing the quality of their results.